Hi guys, welcome to another video tutorial by No Statistics No Talk. In this tutorial, we are going to have a look at another type of non-parametric test called chi-square test, and we are going to focus on independence test. First, let's have a look at what is chi-square test. Chi-square is a quantitative measure used to determine whether a relationship or correlation exists between two categorical variables. There are two types of chi-square tests, namely independence test, which will be discussed in this tutorial, and goodness of fit test. So now let's have a look at what kind of situation that requires the use of independence test. Suppose a scientist wants to know if education level and internet spending behavior are related for all people in Malaysia. So as you can see from this equation, there are two variables which are categorical because each of them has its own specific characteristics. So that explains why this equation is a non-parametric question. And then we are going to have a look at whether these two variables are related, or in other words, whether there is a relationship between the two variables. So apparently, in this question, independence test is the most suitable test in order to investigate the relationship or the independency between the two variables. If the two variables are correlated, their values tend to move together, either in the same or in the opposite direction. So this statement can be better illustrated by these figures. In the first example here, you can see that the values of the two variables move together or in the same direction. So we name it as a positive correlation. Or we can say that the two variables have a positive correlation. In the second example, we can see that the values of the two variables move in the opposite direction. One is increasing and another one is decreasing. There is still a correlation between the two variables, but in an opposite way, and we name it as negative correlation. In the third example, you can see that there is no specific trend of the values between the two variables, or we can say that variable 1 is actually not affected by variable 2, or we can also say that there is no correlation between the two variables. Now let's have a look at what are the steps that we have to perform in order to use independence test. The first step is to set the hypothesis, both null and alternative hypothesis, followed by the second step, that is to compute chi-square statistics. The formula for chi-square is given as follows, where O stands for observed frequency and E stands for expected frequency. In order to solve this, we have to create what we call a contingency table. We're going to have a look at this at the next slide. In the third step, we have to make a decision by comparing the computed chi-square value from step 2 and the tabulated chi-square value obtained from chi-square table. The rule of thumb that we have to refer is given as follows. We reject the null hypothesis if the value of chi-square statistics is more than the chi-square value from the table, and we accept the null hypothesis if it is the other way around. The final step is to make a conclusion. We have to state the accepted hypothesis in detail, and we have to be specific with the variables that we analyze in the problem. Now let's have a look at how we're going to generate a contingency table. The table is actually an extension of the data given originally in the question, whereby the data given represents observed frequency, or O. So what we have to look for in extra is what is the total O of every row and what is the total O for every column. And also we have to find out what are the values of e and the values of O minus e squared divided by e. Because at the end, we have to solve this equation whereby the chi-square is the summation of O minus e squared divided by e. This is an example of equation that requires the use of independence tests. A scientist wants to know if education level and internet spending behavior are related for all people in Malaysia. Given the following data, calculate chi-square, an appropriate measure of association, and interpret the results if the alpha is equal to 0.05. So each of the variable here has three levels. Education level has the level of bachelor, master, and PhD, whereas for the internet spending behavior, the levels are occasional, frequent, and highly frequent. Now let's have a look at the solution for this equation. First, we have to set the hypothesis, both null and alternative. So this is the original data given. So the null hypothesis should say internet spending behavior and education level are independent, or you can also say there is no association or correlation or relationship between internet spending behavior and education level. The alternative hypothesis should say internet spending behavior and education level are dependent, or you can also say there is an association or correlation between internet spending behavior and education level. In the second step, we have to compute the chi-square statistics given by this formula. In order to solve this equation, we have to create a contingency table. This is the original data given to us, where we label the data as O, or observed frequency. What we have to find next is the values of E, O minus E squared, and O minus E squared divided by E. But first, we have to find what are the total of O for every row and for every column. For the first row, the total O is given as 20 plus 15 plus 15, that is equal to 50. The second and the third row has the total O of 48 and 35 respectively. For the first column, bachelor, the total O is given as 20 plus 26 plus 18, that is equal to 64. The second and the third column has the total O of 36 and 33 respectively. The grand total is given as the summation of total O for every row or the total O for every column. So the value is 133. So next, let's have a look at how we're going to find the value of E. Let's see the first column here. The E is given as the multiplication of 50 and 64 divided by the grand total 133, and that gives the value of E of 24.06. And then we can solve for the values of O minus E squared, and O minus E squared divided by E, because we already know what are the values of O and E. Let's have a look at another example how we're going to solve the E value. So the E value of the column master and highly frequent is given as the multiplication of 35 and 36 divided by 133. That gives a value of 9.47. So we have to complete this table by solving the value of E and also the value of O minus E squared per E for every column in this table. Having completed the contingency table, the next thing that we have to do is to solve what is the summation of O minus E squared divided by E, which is actually the formula of chi-square. So in this problem, the chi-square value is given as 2.286. This chi-square is known as calculated chi-square or chi-square statistics. In the third step, we have to make a decision by comparing the computed chi-square value from step 2 and the tabulated chi-square value from the table. This is the chi-square table. The degree of freedom is given as the multiplication of number of row minus 1 and the number of column minus 1. Since there are 3 levels of each of the categorical variable in this problem, the degree of freedom is given as 2 times 2, that is equal to 4. The p-value is equivalent to the alpha value, which is 0.05, and it is given in the equation. So the tabulated chi-square or the chi-square table is given as 9.488. And the chi-square statistics that we have obtained from step 2 is 2.286. Since the chi-square statistics is less than the chi-square table, so the decision in this equation is to accept the null hypothesis. In the fourth step, we have to make a conclusion, whereby we have to state the accepted hypothesis in detail. Since we accept the null hypothesis in step 3, we can conclude that at alpha equal to 0.05, the two variables, namely internet spending behavior and education level, are independent, or we can also say that at alpha equal to 0.05, there is no association or correlation between internet spending behavior and education level. So that's wrap up the 4 steps that we need to perform in order to analyze a non-parametric equation using independence test. So that's all for now. Thank you very much for watching. For more video tutorials on statistics, please subscribe to No Statistics No Talk on YouTube.